right, so today we're going to do section 9.3, but you might want to check and, just know that you are expected to be done with that set. In this set, remember we have one big assignment this chapter for our delta map. All right, so those should be done already. And we're going to go into our notes and page forward a little bit to our notes on 9.3. We've been working with our transformations. We started just practicing plotting points, and then we did translations where we're given a rule that tells you how to slide, so translation is a slide, the figure. And so this is just practice at the beginning, a little bit of review before we hit our new transformation called the rotation. So it says, if this rule maps TUVW onto T prime, U prime, V prime, W prime. Now I could actually go put a fake, I'm just going to go put a fake T right here. What it's saying is the whole four-sided figure gets moved, but I'm just going to move T according to this rule. I should move T one to the left. I'm going to put T over here actually, so I have room to move it 5 up. So I'm going to move T one to the left, and this plus 5 means 5 up. So 1 to the left, and 1, 2, 3, 4, 5 up, and I'm going to put my new T prime here. It says, what translation would map T prime, and again, the whole figure would go with it, back. So I basically just back it up. Instead of going 1 to the left and 5 up, I'll go 1 to the right and 5 down. So I would say XY gets mapped to, and to move 1 to the right, notice I'm just doing the opposite, just backing it up to get back to the original figure. There we go, that's a translation. Now it says I have a triangle, and it's triangle CDE, so I'm going to go graph it. It's got vertices at 1, 4, 3 to the right, 6 up, and 7 to the right, 1, 2, 3, 4, 5, 6, 7 to the right, and 4 up, right there. So I'm going to draw it. I'm going to label it. It will be labeled C, was the first one I plotted at 1, 4. And then I did D at 3, 6. And then I did E over here at 7, 4. And I have my nice triangle, CDE. It says if the triangle is reflected, well, that's our second kind of transformation. And that means I'm going to be flipping it. It says I'm supposed to flip it over the line Y equals, yeah, right? It's a horizontal line. Y equals 2. So I'll go draw that here. There's my reflection line. And I said the easiest way to do this is to just walk to it. Like, because I can't fold my smartboard over. But if I did, it would take 1, 2 steps to get on the line of reflection and then 2 away. So my new C, if I were to fold it over that line, would land right there. And it says, what are the coordinates of C? So I will say that it would now be 1 to the right and 0 up if I were to flip C. And the whole triangle would go with it. So like obviously E would go here and D would go 1, 2, 3, 4, 5, 6 to get there. 1, 2, 3, 4, 5, 6 to get away. And that would be my new figure. Whoops, I just lied. Sorry, I didn't walk to the line of reflection. I walked to the axis, so let me fix that. It'd be 1, 2, 3, 4 to get there, 1, 2, 3, 4 to get away, and there's my new one. All right, and last in my review, it says, what are the coordinates of the image of -3, 5, this is my x, this is my y, when we are reflected over? And now this is where we use those rules that we wrote down in our section for 9.2. When we flip over the y-axis, we have a rule on the previous page that says we get sent to the opposite of x, comma, y. You don't really need to go plot it. You could go 3 to the left and 1, 2, 3, 4, 5 up, and you could physically fold it over this y-axis, but where you would end up is over here at the opposite of the x, 3, and the same just going to use our rules. Over the x-axis, our rule said that the x stays the same and the y goes opposite. So I don't need to go over to the grid to plot. I'm just going to say, well, the x stays the same at a -3 and the y goes opposite. Over the line y equals x, we said you just swap out the x and the y. So our rule actually says xy goes to yx. Well, then I'll just reverse it. 5, -3. And then we said over y equals x that it swaps and takes the opposite. So our xy goes to the opposite of y, opposite of x. And again, I back up at this original point. I go to the opposite of y, which is a -5, and the opposite of x, which is a 3. So that's a review of yesterday's flips, also called reflections, and they are isometries because the size does not change. Well, today we're going to work with rotations. So a rotation is a transformation that turns a figure about a fixed point that we call the center of rotation. So down here, I'm going to make this one would be said that it has a center at P, down here in the bottom left corner. A rotation is an isometry. When I turn things, they don't change size. Recall, with an isometry, we've said this a lot, that we mainly stay the same size, and technically shape. Rotations can be done with the clock, so if you were to look up at the hands on a clock moving, we call this direction when we're pulling it that way, clockwise, against the clock would be going this way, and you'll be told, and if not, I'll tell you what to assume. So when working in the coordinate plane, okay, what's a coordinate plane? Well, vocabulary, that's our x-axis, y-axis, and we usually have the grid, right? Just like I had up there, coordinate plane. It says you are to assume that the center is the origin, 0, 0, unless told otherwise, and you're going to assume that you're going to move counterclockwise. So if it just says 45 degrees, you're going to assume it's 45 degrees against the clock unless told otherwise. So what we're going to do is go discover, because there's patterns for these as well. So we're going to stop right now, and we're going to all log into our Delta Math, and we're going to go do these 3 together. So you pause the video, open your Delta Math, and in class we will have walked through these 3 main rotations together. So here's my Delta Math. We're going to go into where it says rotate a figure about the origin guided. Okay, we're going to do this one first where it says it first. So right after reflect a figure over a line, the next thing says rotate. Okay, you're going to click. And again, feel free to pause. And we're just going to follow the directions here. I'm going to maybe see if I can blow this up a little bit. What does it say I'm supposed to do? I'm going to be moving or rotating this figure 180 degrees. I'm going to have the computer do it for me, and I'm going to see if there's a pattern. So it says draw a circle at the center of rotation, which is the origin, unless otherwise told. So I've got my hand hovering here over the origin, the yellow dot, so that one of the vertices is on the circle. So I'm going to go just get that first one right there. So I just made a circle with this vertex on the circle. Click and draw a line through the yellow dot and the vertex. You're going to click on the yellow dot, and you're going to turn your line and line right up with the vertex. Now draw a line through the yellow center that's perpendicular. Well, how do we make sure we're perpendicular? We use slopes. So I'm going to use the fact that this line right here is going up 3 over 2. And perpendicular lines, we flip and do the opposite. So instead of 3 over 2, we're going to do -2, 3. Whoops, sorry, I clicked on that. So up 3 over 2. Now we're going to go down 2, and we're going to go over 3. You'll notice I made perpendicular lines. Now it says I'm supposed to grab this red dot
and do a 180. Well, we know 180 is a line, so I'm just putting it on the other side. Watch that red dot go. And now we're going to see what happens to those vertices, and we're going to come up with our pattern. So -4, -6, this bottom one, turned up to this top one at 4, 6. If you notice, all that happened is they became opposites. And that's what a 180 does. Like if you do a 180 in your car, you're facing the opposite direction. So without looking at the grid, I'm going to see and assume that's 1, 5, and I'm going to go check. Did -1, -5 down here go to 1, 5? And it did. So my pattern for the 180 is we just take the opposite of both coordinates. Go ahead and hit try values. You're correct. You can go ahead and submit. Okay, now we're going to go do the other two. Okay, the other two we're going to do is this next guided one. So click, go into your problem, and we're going to be doing a 90-degree against the clock or counterclockwise, and we're going to come up with a pattern for that as well. Starts the same way. It just says draw a circle until you're on one of the vertices. And then we click and we draw a line connecting. And now we're going to do one perpendicular. So we are going to say, well, this is down 2 to the right 1. So -2 over +1. We are going to do the opposite reciprocal. So we're going to go up 1 and over 2. Again, you can always pause the video. Now it says rotate 90 degrees so that, and against the clock. So I'm pulling it up right to there. Again, red dot. 90-degree turn against the clock, and let's see if we can come up with a pattern. So 5, -7 is this peak. After the turn, it went to 7, 5. It looks like I took the opposite of the y value and kept the x value. Let's try that here and see if it works. I'm going to take the opposite of the y value, which would be a 1, and I'm going to keep the x value. Let's see if that's what actually happened to this point right here, 3, -1. On the turn, it went to 1, 3. So, perfect. Let's do that one here. What did I say we're doing? It looks like we're taking the opposite of the y value and keeping the x value. And we'll go write these in your notes. All right, go ahead and submit. And then back, we have one more to do. We're going to go 90 degrees with the clock. Okay, so again, we start off the same way. We're going to pull a circle till it lands on a vertex. We're going to connect the center with the vertex. We're going to draw a line perpendicular. So we're going to look at this slope going down 1 over 4. We're going to flip that. We're going to go up 4 over 1. Okay, negative reciprocals. Now we're going to turn with the clock. 90 degrees. So I'm pulling this as if the clock is pushing it this way, and we're going to go see if we can come up with a pattern. So let's go focus at 2, -8. It's this peak right here. It turned over onto this far left one. It went to -8. So it looks like the y value came first, and then it went to -8, -2. It looks like I have the opposite of the x. Let's try that on this one. Let's do the y value first, and then the opposite of the x. Let's see if that worked. Did 7, -3, turn on to -3, -7? And it did. You can see it. All right, so let's do this last one. And what did I say we're doing? It looks like we're putting the y value first on all of these. The y's are going first, and then we're taking the opposite of our x values. Hit try. I'm correct. And hit submit. All right, now let's go get those patterns in our notes now that you saw them, okay? So back into the notes. Once you have the patterns written down, it's really quite easy. All right, so let's go back into our notes and let's kind of do a visual here. Let's call this one the 90 degrees counterclockwise. 180 is either way. And then this is 270 counterclockwise, because we assume counterclockwise unless told otherwise. But a couple things to note is that if you go
90 degrees against the clock, it's the same as going 270 with the clock. So this would also be called a 270 clockwise. Similarly, with the one on the end over there, if I did 270 degrees against the clock, the same turn could have been done going 90 with the clock. So this is also called 90 clockwise. They mean the same thing. All right, you don't need to memorize that. We're going to have a little table here. But let's go take a look at these patterns. We just did it in Delta Math, but let's just go grab a single point C and see what happens. Actually, it looks like we're focusing on B on that one. So let's go take B right here, turn onto B prime with a 90 degree against the clock turn. And you'll notice what happened is that the Y came first, but it was opposite, and then X is in the second slot. And it happens with all of these. So like C, the Y would come first, and then, the Y would be first but opposite. Let's see, keep seeing this. And then at the X value. So let's go over here and look at point B. It was at 2,5, and now a 180 just does the opposite. So that's our rule for the 180. These are the ones that we just did in Delta Math. And now let's look at this one. Let's focus on, let's look at C to C prime. What's happening here? It looks like the Y value is going in the first slot. The X value is going in the second, but with the opposite sign. And we're just going to use those patterns. Makes it really easy. They're all on this chart right here, so we'll just practice it once before going to your homework. So here's my original X, my original Y for all of these. This says 90 degree clockwise. 90 degree clockwise is going to put the Y value first, so the -3 will come first, and then it's going to have the opposite of the X value. Done. 90 degree counterclockwise. So 90 degree counterclockwise, okay, is this pattern. It's going to put the opposite of Y, and again, we're going back up to this point right here, X, Y, and it says to do the opposite of the Y, which will be the opposite of -3, and then just keep the exact same X. What does the 180 do in either direction? It just takes the opposite of them as they are. Okay, so -7 to a +3. And then last up, it says a 270, and it doesn't tell me, so we're going to assume counterclockwise when not told. Okay, so 270 counterclockwise. And again, it's that 7, -3 that we're working with. So our X is 7, our Y is -3. Our rule says to put the Y value first, my -3, and then take the opposite of my X value. Now you'll notice I have two answers here that are the same, right? And it makes sense why they're the same, so let me explain why. This guy and this guy have the same answer, because I told you, if I were to take and go 90 degrees with the clock, correct? There's a 90 degree with the clock turn. It's the same as going 270 against the clock. 90 right here, and then these 3/4 make 270, and for both of them, I landed at the same spot. So that's why for both of these, we landed at the same spot. So your assignment is in Delta Math. Go ahead and continue with the rotation stuff that's listed on the first page of your note packet. So again, if ever you're